All right, Chris, Andrew here. Looking at your data from Fremont, that is, hopefully you can see the cursor a lot better now that this is bigger. Looking at your data from Fremont, that's all this data here. So you did 5 runs initially with one propeller on Saturday, and then another 5 runs with a second propeller, and then you did one test hit on Sunday. That was kind of a really fast start speed. So you can tell the difference between the props. The first prop that you did here, it definitely was slightly, um, let's say, shorter in terms of the prop. It was 109 RPM per mile an hour. And then when you change the prop, so I think the very last run of the first 5, I think you did 4 runs with the first prop and then 6 runs with the second prop, actually. So it's about 4% taller, the second prop. And initially it wasn't as good, but by the time you learned how to drive around the second prop, it actually was better. So you were hitting about 10,100, 10,200 RPM at about 95 to 97 miles an hour with the second prop, just over 97 miles an hour. I'm not sure what you had the steam wheel set to on the PV ECU, but I put 96 here for everything. You said you were adjusting it. If you want to let me know and fill that in, but the EGTs were definitely hotter, so I think you probably leaned it down from 96. You can see here on the right bank, especially, it's about 30 to 20 to 30 degrees hotter than what you had in Sneeds up here. So you can see that data over here. So an important thing to note is pretty shortly I'll have made for you a cable that'll interface with the AIM dash to connect to your PPE ECU, so you don't have to write any of this down. And we can see the fuel curve that's in it, and you can start making adjustments to it. But looking at this data, just in general, all of your data from day one back in July, you've progressively gotten better. The times have gotten lower. The boat has gotten faster. So that's good to hear. Even during within a single day, you get more consistent. You're pretty consistent as it is, but you get more consistent and definitely better as the day goes on. So you can see um, the times drop as you go in this direction here. And then when you change the prop again, you kind of suffered a 60-foot hit here where initially the trim wasn't perfect and you bobbled coming out of on the whole shot coming out of the water on plane, and then you progressively improved. And it's not like you really made illegal start speeds here. Yes, it was slightly higher, but you improved a pretty dramatic difference. If we look at all of the start speeds in the 60-foot times and we graph that, that's what you're looking at here. Okay, so this axis is showing start speed. So you have a pretty big cluster of data here between 6 and 7.5, which makes sense because that's your start speed. And then your 60-foot times are on the vertical axis here. So if you obviously there's some spread to the data here because you might not have the trim perfectly set, the motor might bobble, that type of stuff. But in general, you're going to lose for every 2 miles an hour that you go slower, you lose a tenth of a second of 60 foot. Okay, so these here are not really that dramatic of a difference. You were about 2/10 of a second faster than some of the first runs, which is helpful um, because you were just driving it better, to be honest. Especially this last run here for an Allison. This is one of the quickest Allisons I've ever seen in this class, if not the quickest. So definitely useful. The second prop that you were using, in my opinion, is better overall. You had faster times outright with it. Yes, the short track is not as good, at least with the trim that the initial settings of the trim that you had, but the way you were driving at the end, the second prop is definitely the better prop to choose. Um, I will say that it's not really a 105 class prop on that boat. In my opinion, you're only going about 97, 98 miles an hour. It's breakout worthy on a 95 class, but I would say that you still need a slightly taller prop. You're going 10,000 over 10,100 most of the time. Most of the runs actually were not 800, even though this is showing the 800-foot times. Most of the runs you kind of backed off at about 750 feet to 760 feet. So these are the 800-foot times, but you backed off a little bit. So your real time here, if you kept your foot to the floor, just the course was not exactly 800 feet. But if the course was exactly 800 feet, these would be slightly faster. Okay, so all that's good information. If we look at the AIM data in a little bit more detail, to kind of understand, well, where did you make these improvements as you started driving the boat slightly differently, and how is the second propeller different from the first propeller? So all of the kind of reddish color ones here are the first propeller, and you can see that the first 5 runs that you did, when you smack the throttle, you kind of cavitate to about 6,700 here at about 15 to 20 miles an hour, and then it kind of hooks up. This last one here might actually be a different prop here, based on what I'm looking at. So yeah, most likely that's a different prop based on this data. So you had one run here with a different prop, and you can see how this one is slightly lower. It's only about 64, 6,500, which is kind of what all of these are. But you can definitively see the difference here in the RPM. You're dropped for a given speed. You're about like 400 RPM slower. So at 60 miles an hour, it's about 400 RPM less. Okay. But the way the shape of all of this is pretty similar. So this is a little bit hard to tell and compare differences here, but an easier way to do it is with longitudinal acceleration. So you can see that all of your runs, actually, I didn't mention that in this particular run here. So your longitudinal acceleration is this column here. So you have pretty, especially with the second prop, you had pretty good values here, almost some of the best that you've seen. So the prop is hitting, or I guess the setup is hitting really hard on the hole shot, especially with that second prop. The first one honestly wasn't that good. It ran good times, and you did well just because it's a pretty short prop. But if you're facing, the problem is you'd break out with the second prop in a 95 mile an hour class. But in a 95 mile an hour class, that first prop is pretty good. The second prop is better if you're just looking at outright speed. Okay, so now back to the aim data. So if we compare kind of how these props are hitting, there's a definitive difference right out of the gate, and especially the top end. You had kind of a bigger dip here. So as the boat kind of settles as it comes out of the water, it might touch down. You kind of touch down a lot of these red, pink, purple runs, or sorry, red, yellow, and kind of orangey runs here. This is with the shorter prop, and sometimes it touched down here, and you had few bobbles. So that's what this is looking like here. The blue runs here they have a harder hit, and the over rev between 75 and 95 is definitely better. You can see that kind of here. So all of actually about 85 to 95 is definitely better. It doesn't sign off as quickly. So that's something that's interesting. Just as a sanity check, if you looked at, let's say, the the EGTs between each of these runs, they shouldn't be dramatically different, which is kind of what you'd expect. They're all about the same. It just really depends on what start speed you had and what start EGT. So you can kind of see that here. Ignore this part here. That's when you're backing off, but you're starting between 260 and 380 on the port side, and you're ending between I don't know 860 and 880 on the starboard side. In general, it's hotter, so you can see that here. These numbers all went up now. So they're between 340 and 420 at the start line. And then at the ending, you're about 920 to 940. If you compare one test to the other, you can kind of see that the EGTs are identical. It's just shifted here in terms of mile an hour. Okay. Which is pretty much what you'd expect, because you didn't change really that much of the settings on the motor. You may have adjusted the ECU one or two numbers, but as far as these peak EGTs go, you're somewhere between 920 and 940 on the right bank, and on the left bank, somewhere between 870 and 890. So there's about a 30-degree spread, which is normal. So you should get the trim timer, or sorry, the trim sensor in the mail. That way we can optimize your trim timer. I sent that out a couple Monday this week, so you should have that shortly. And then I'll send you, as soon as I'm done making it, the ECU patch cable for your AIM system. That way you can kind of log all the data from that as well. It doesn't look like there's any dramatic health issues with the motor whatsoever in terms of your fuel pressure. It's pretty bang on 55 no matter what. When you back off, it sloshes slightly, so I really wouldn't worry too much about that. You can see that here. As soon as you back off, I will go to this plot and show you speed here in a second. So you can see that this is the peak speed, and the moment you slow down a second or so later, the fuel sloshes forward, and you're getting kind of a dip in the fuel pressure, which is to be expected. But under power, you really have nothing to worry about. Like it's exactly 55, so the fuel system looks healthy. As far as the water pressure goes, you have pretty consistent water pressure. It didn't change dramatically at all, and you're kind of idling it at about 1 psi, and you're ending the run anywhere between 12 and 14 psi, which is what you'd expect. You could play with the engine height slightly if you want to see it'll gain you some top end at the loss of some of the bottom end. With the second prop, it might not be a huge issue. So let's just bring back speeds here, and we will look at this graph, and we'll compare them all so you can kind of see where you stack up and how everything changes. I'll zoom in here. There's a lot of runs obviously in one thing here. That's why kind of the spreadsheet's the best, but the spread between the slowest run and the fastest run is less than 0.4 seconds. But you can kind of see here where each prop gains and loses. And that kind of boils down back to what you were seeing here. Okay, so the taller prop, the second prop that you had for the 105 class, it hits harder. The mid range is similar, kind of because you just have a nice flat progression here. Some of the runs you still had a dip, like what you had here, but it's definitely more consistent in the second prop. And then the top end is definitely better. You have this nice bump in acceleration at the top end where you don't have it. It kind of signs off at about 5 miles an hour earlier. So feel free to reach out if you have any questions with regards to some of the engine questions you were having on Russell Peterson's engine. It it definitely the horsepower range of a stock engine is about stock drag. The power head alone, depending on the settings of the ECU, could range from 355 to 370, low 370s, let's say, and that's with 21cc heads. If you go slightly tighter, it might make a little more torque and a little less power. As soon as you modify the sleeves and the port timing internally to the engine, that's where you're getting in the 380, 390, 400 range. And then when you do some other modifications to the airflow on let's say the reed valves, some different custom cylinder head domes, different SVS, a larger SVS. This is the stuff that we offer as well in our drag builds. Then and potentially a different fuel. We make an E85 kit to run ethanol on it as well. Then you're in the 415, 425 range. Okay, and I realize every dyno reads a little different, but if you look at our website and click on the SR package, SR5 is probably the one you want to look at. It'll show you a power curve and kind of where it makes peak power. It's about 9,000 RPM, which is where you're kind of spending. I'll show you the histogram in a drag run here. Give me 1 second. Where you're spending a lot of your time. I'm just going to zoom in. So this is showing from beginning to the end of the run here, okay? Now this is showing, give or take, where you're spending most of your time. Okay, so you're 22%. In this case, you're anywhere between 28 and 42% at anywhere between 9 and 10,000. So you're spending a lot of time there. The last pretty much 3 seconds of the run, you're spending between 9 and 10,000. So that's kind of where the peak power is, and that's how we port them. But you need a spread of power between 6,000 and 10 grand. Okay, 6,000 is how it determines how the motor hits. So we pretty much optimize the power between 6,000 and 10,000. Obviously, you're idling in here, so there's a half a second or a second or so, but the motor spends barely any time between 2,000 and 6,000. So that kind of gives you an idea here in terms of time. All changes from percentage to actual time here. So for every run, it's anywhere between 2.4 seconds and almost 4 seconds at above 9,000. And you have about 2 seconds between 6 and 7. And then you kind of continuously accelerate between 7 and 8 and 8 and 9. Like I said, if you have any questions, feel free to reach out. Hopefully this video turned out better in terms of the audio and some of the way that I'm showing the cursor here. So yeah, feel free to reach out if you have any questions. Thanks.